students, welcome to Narayana Digital Classroom. So in this class let us discuss the two centers, EXCENTER of a triangle and Circumcenter of a triangle. In the previous class we discussed centroid of a triangle and incenter of a triangle. So in this class, EXCENTERs of a triangle and Circumcenter of a triangle I am going to explain. So what are the EXCENTERs of a triangle, Circumcenter of a triangle? First see the EXCENTER of a triangle. Already we know in center of a triangle it is denoted with I. Now EXCENTER of a triangle is a point of intersection of internal angular bisector at vertex A and external angular bisector of other two is called incenter. The center is see here. So here this is a triangle, let us take. So this is internal angle. This is internal angle A. This is one internal angle bisector, and if I extend AC, here I can get one external angle. If I extend AB, I will get another external angle. So here EXCENTER is a point of concurrence of one internal angle bisector and two external angular bisectors. This is internal angle bisector, this is external angle bisector, this is external angle bisector. This is exterior angle, na? So this bisector and one internal angular bisector, these three will coincide or meet at one point, that is called EXCENTER of a triangle. Okay, na? So one internal angular bisector and two external angular bisector, the point of concurrence is called EXCENTER. This is EXCENTER. Incenter is denoted with I. In the previous class we discussed. Now what is EXCENTER denoted by means this is I1. Why I denoted with I1 means, see here, so this is a I1 EXCENTER, and this EXCENTER also equidistant to sides of triangle. If I draw one circle, the circle is called X circle. Okay, now this is center, and from this center to distance to this side BC, by taking radius, if I draw one circle, there the circle will touches all the three sides of a triangle. So one side BC and two extended sides, that is extension of AC and extension of BC, such a circle is called X circle. What is the circle? X circle, and its center is called EXCENTER. It is denoted with I1. Now a simple question, how many EXCENTERs does a triangle have? Means here there will be three EXCENTERs. There will be three EXCENTERs. Once again, one internal angular bisector, two external angular bisectors. The point of concurrence is called EXCENTER. So this is the center, means a point, it is denoted with I1. So by taking this as a center, point center, and by taking the distance from point to side BC as radius, if I draw one circle, it touches the three sides like this, that is called X circle. So let us see how many circles does a triangle have. So here there will be three sides and three vertices. So there will be three X circles obviously here. One is vertex A opposite to one X circle, vertex B opposite to one X circle, vertex C opposite to one X circle. Is it or not? If you take this is a triangle ABC, okay now, if I am extending the sides, one internal angular bisector, these two external angular bisectors meet at one point. This is EXCENTER. This is EXCENTER, which is opposite to A, is denoted with in general I1. And similarly there will be another EXCENTER also which is opposite to B, that is denoted with I2. So I2 is formed by internal angular bisector of B and external angular bisectors of A and C. Okay, now A and C. This is I2. And similarly there will be third external X circle or EXCENTER which is opposite to C, that is denoted with I3. So I3 is one internal angular bisector, means internal angular bisector of C, one internal angular bisector of C, and external angular bisectors of A and B, like this. Just imagine this is a rough diagram. So one X center which is opposite to A, it is denoted with I1. X center opposite to B, it is denoted with I2. X center opposite to C, it is denoted with I3. So main triangle is this is ABC. In middle there is a ABC triangle. There we can draw three X circles. One is opposite to A, one is opposite to B, one is opposite to C. That is denoted with I1, I2, I3. Okay, now this is I1, I2, I3. For example, let us see the properties. So if I take this is ABC, the ABC, this is roughly I1 here, this is I2 here and I3 here. Okay, now I1, I2, I3 are X centers. If I join this, there I can draw, sorry, see here, like this. This is ABC, this is ABC. So here I1, I1, so here I2 and here I3. So if I join this I1, I2, I3, there I get one triangle like this. This triangle I1, I2, I3 is called excentral triangle. Excentral triangle of ABC. What is that name? Excentral triangle of ABC. Because by joining excenter, the triangle is formed. Excenters triangle of ABC. And coming to this excentral triangle, is the orthocenter of this excentral triangle is also equal to incenter of triangle ABC. So we did not complete orthocenter. It will come discuss. Listen, remember this point. The orthocenter of this I1, I2, I3 is incenter of triangle ABC. Now let us see what is the formula for this excenters. Already in the previous class we discussed the formula for incenter of a triangle. Now here three excenters are there. So what are the formulas for finding excenters of triangle? If the triangle what says A x1 y1, B x2 y2, C x3 y3, as well as the side opposite to A is called denoted with A, small a, and side opposite to small b is side opposite to angle B is a small b, side opposite to small C, angle C is a small c, then see the formula for I1, I2, I3. Here I1 formula is A x1 minus A x1 plus B x2 plus C x3 by minus A plus B plus C, comma minus A y1 plus B y2 plus C y3 by A minus A plus B plus C. So in the previous I formula is Ax1 plus Bx2 plus Cx3 by A plus B plus C, Ay1 plus Vy2 plus Cy3 by A plus B plus C. Now this is formula for I1. I1 formula, in the I1 formula there will be minus symbol for A, small a, here and here. Okay, now similarly the I2 formula is, I think you can guess the formula, I2 formula. So I2 means there will be minus symbol for B, means Ax1 minus Bx2 plus Cx3 by A minus B plus C, comma Ay1 minus By2 plus Cy3 by A minus B plus C. This is formula for finding excenter opposite to B, I2. And coming to I3, Ax1 plus Bx2 minus Cx3 by A plus B minus C, comma Ay1 plus By2 minus Cy3 by A plus B minus C. I think you can remember easily. For I1 there will be minus for A, for I2 there will be minus for B, for in I3 there will be minus for C. In I, all the three are positive. So by using these formulas we can find excenters which is opposite to what says A, B, C. Ax1 y1, Bx2 y2, Cx3 y3. So what is excenter once again? The excenter is a point of congruence of one internal angular bisector, two external angular bisectors. Let us go for the next center, Circumcenter of a triangle. Circumcenter. What is the next center? Circumcenter. Circumcenter of a triangle. So see what is the circumcenter. So circumcenter of a triangle is defined as point of concurrence of perpendicular bisectors of sides of a triangle. The point of concurrence of perpendicular bisectors of sides of triangle is called circumcenter. It is denoted with S. Circumcenter, it is denoted with S. Let us see what is S. So see here, first of all, what is a perpendicular bisector? Perpendicular bisector of sides. So see here, there will be three sides for triangle ABC, AB, BC, CA. Construct perpendicular bisector. Perpendicular bisector means a line which is perpendicular to the base and bisecting the side is called perpendicular bisector. Is it or not? This line is perpendicular to AB as well as bisecting. Bisect means this is midpoint. So this is perpendicular bisector. Like this, there I can draw three perpendicular bisectors to three sides. So these three perpendicular bisectors will pass through a one common point, that is called circumcenter of a triangle and denoted with S. Circumcenter of a triangle and it is S. And this S is equidistant to vertices of triangle. This S is equidistant to vertices of triangle. Means SA is equal to SB is equal to SC. Distance from S to A, S to B, S to C are equal. Means S is a center,